Well, we are starting chapter 2.4, binomial distribution. In previous class, we have shown some examples. Today, we'll derive some properties of binomial distribution. So I hope all of you are ready. I'm going to present. Uh, can you see the book?
Yes.
Yes, sir.
Yes, sir.
Okay. Uh, I'm starting with the binomial theorem. I think you know the binomial theorem what it is. Usually, you can remember, like if I write a plus b or 3, you can write a cube plus 3 a square b plus 3 ab square plus b cube. Am I right?
Yes, sir.
You can easily write this sum of 3cx a to the power x b to the power 3 minus x, and you put x equal to 1, you will get a cube. Uh, okay, sorry, x equal to 3, then you will get a cube, because 3 is 3 equal to 1, a cube, then b to the power 0, actually a cube. If you put x equal to 1, you will get 3, 3 to 1 is 3, a square b, and so on, isn't it? Similarly, if we get n terms, how many terms here?
In terms.
n
Enter.
n powers, then you can write in this form. That is true for all binomial series. So you can see, if ncx, x between 0 to n, b to the power x, a to the power n minus x, this is also valid because binomial theorem is commutative. It is also valid for ncx, a to the power x, b to the power n power x. It doesn't matter which one take first, a or b. Okay. In both of the sense, it's a plus b whole to the power n. Do you understand? According to the binomial expansion, what you did in intermediate level. Now, if I put a equal to p, b equal to p, a equal to 1 minus p, once again I'm saying it doesn't matter. You can put a equal to p, b equal to 1 minus p. As this is commutative, there is no problem at all. Then we get LCX p to the power x, 1 minus p. 1 minus p is what? Q, right? 1 minus p is what?
Q.
Q. So we can write this q to the power n minus x, or 1 minus p to the power n minus x. Then according to this, you can write a plus b, that is 1 minus p plus p to the power n. Now p cancel. 1 to the power n is what? 1.
1.
That's why we can say, since this is a total probability, the total probability is what?
1.
1. That's why the PMF what we have taken for this distribution is valid. Now you have to find the moment generating function. Be careful, we'll use this several times. Now come forward for finding the moment generating function. Here, moment generating function, we know mt is expectation of e to the power tx. So e to the power tx fx. Here, we'll take ncx. Here, e to the power t and p, both of them have the power x, so we can write them within a bracket. Can you write it?
Yes.
Then according to binomial theorem, once again, we take this is P, this is A, this is B. So A plus B whole to the power n. That is 1 minus P plus P to the P e to the power T to the power n. Sometimes we used to write this is also in this form. Mt is equal to 1 minus P taken as Q plus P to the power T whole to the power n. There is no problem at all. Yeah, same. Now we got the moment generated function is Q plus P e to the power T whole to the power n. But we have to make sure m0 equal to 1. Now put m0, that is t equal to 0, then we will get q e to the 0 equal to 1, so p whole to the power n, and we know p plus q equal to 1 to the power n is equal to what? 1. Since this is 1, so we can say this is valid moment generating function. Do you understand?
Yes, sir.
So we have seen that the PMF is valid. We found the moment generated function, and now we verified that this is valid moment generated function. Since we have the moment generated function, we use the moment generated function to find the mean and variance. Just see once for once. Actually, you need not to retype them. You have to just use them for our next exercise. We have to take the first derivative with respect to t, then the second derivative with respect to t. It has been done here. Just put mu, that is the mean, is equal to m dot 0. If you put it here t equal to 0, you'll get np only. Np, because here it will be 1. It will be 1, only np will remain. Once again, sigma square is equal to m double prime 0 minus m prime 0 whole square. Now put here m double prime 0, that is t equal to 0 here, you will get this. And from here put np whole square. After simplification you will get this. Also you can write here, this is npq. What we can write?
NPQ.
Now we are going to make the summary of the work. Here 3 things we found. The mt, we found mt is q plus p to the power t. I want to write whole to the power n, where n is number of trial, p is rate of success, q is rate of failure, mu is np, and sigma square, that is the variance, npq. So by continuing, we can write standard deviation. The standard deviation is root over npq. And for a single trial, single binomial trial, we will put n equal to 1. For single binomial trial, we will put what?
1.
N equal to 1. Otherwise, all the case have the same system. Do you understand?
Yes, sir.
Let us see some example. Suppose that observation over a long period of time has disclosed that on average 1 out of 10 items, please don't think only 10 items given. They are assuming for probability 1 out of 10 item produced. মানে প্রতি 10টায় 1 out of 10 produced by a process is defective. প্রতি 10টায় একটা ডিফেক্টিভ। তার মানে বলে না যে তোমাকে 10টাই বানাবে। ব্যাপারটাকে বুঝতে পারছো? They have said out of 10. So what is the rate of defect? 1 out of 10, right? So what? 0.1 is the rate of defectiveness. So what is Q? 0.9, okay? Select 5 items. So here n equal to what?
5.
5 items independently from the production line and trace them. Let X denote the number of defective items so n equal to 5 items. Then this is the binomial distribution having 5 items with probability of defectiveness is 0.1. Then easily you can write fx. What will be the fx? 5cx 0.1 to the power x 0.9 to the power 5 minus x. Do you understand? Hello?
Yes, sir.
Now let us find the mean and variance. The mean will not actually in exam write this in ex. We will write mu. Mu is np, right? This is 0.5. And the variance in exam we will write this as sigma square. Okay, in your exam you will not find in this form. You will find this in sigma square. Sigma square is npq, that is 0.45. Now they asked us to find, for example, the probability of observing at most one. At most one, that is less than equal 1. At most 1 means less than equal 1. What is at most 1?
Less than equal to 1.
Less than equal 1. Silent place. And what is at least 1? Greater than equal 1. What is at least? Greater than equal 1. Okay, so at most 1, that is less than equal 1, that is x equal we have taken x equal to 0 and x equal to 1, and after the simplification we get what is the probability? 0.9185. 0.9185. Okay.
Yes, sir.
Now exercise. For exercise, what should we do? We'll do 4, 5. Actually, these maths are very similar, so I'll do some, and some of them will be homework. 4, 5, 6. Then 8, 9, 10. These maths are easy. You have to just understand what the question says. 11 or 13. Where is 13? Then 17. 19, 20. So I'm telling the serial once again. Please write it. 4, 5, 6, 8, 9, 10, 11. 4, 5, 6, 8, 9, 10, 11. 17, 19, 20. Okay. Hello. Can you hear me?
Yes, sir.
Okay. I'm leaving 4 as homework. I'm going to do number 5. What does 5 says? In a lab experiment involving inorganic synthesis of molecular precursors of organometallic ceramics, that is actually this is a chemical reaction to to make the organometallic ceramics using some molecules. The final step of 5-stage reaction involves the formation of metal-metal bond. Actually, this is not our question. This is the chemical description. Our question start from here. The probability of such a bond forming is P is 0.02. P is given. X equal to the number of successful reactions. X is number of successful reactions out of n experiments. How many experiments they done? They have done 25 experiments. They found the success 20%. So how many percent they failed?
25.
No. They tried 25%. They got the success 20%. So what is their rate of failure? 80%. What is the percentage of failure? Now, according to the question, the number of trial is 25. Obviously, they are independent to trial. The rate of success is given as 0.2. So rate of failure, we can find in a straightforward way 0.8. So you must write the PMF first, whether you ask to write this or not. 25 Cx 0.2 to the power x 0.8 to the power 25 minus x. Sometimes you can see this can be written as the binomial distribution with 25 trials with probability of success 0.2. Can you write it? Okay. Now, what they want actually? They ask to find the probability x at most 4, the probability x at least 5, the probability x equal to 6. So 4, 5, 6. Many things we need. We have to find the mean, variance, and the standard deviation. Now, they need probability at most 4. We first have to find y. I will show later. X equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4. Now, how can we find it? How can we find them? I'm showing one. X equals 0, that is 25 C0, 0.2 to the power 0, 0.8 to the power 25. After calculation, you will get 0.0038. Okay? Do you understand?
Yes, sir.
Similarly, when you put C equal to 1, 2, 3, 4, you will get 0.0236, 0.0708, 0.1358, and 0.1867. We have taken some of the probabilities from x equal to 0 to x equal to 4. But question will arise, why? First one, they said to find the probability at most 4. What does it mean by at most 4? At most means less than equal 4. Then just have to take some. We already have found them. Just put here. And after putting those values, you will get 0.5 4207. Do you understand?
Yes, sir.
Next, they say to find at least 5. At least 5 means this is right. Now, you can see A and B are the complements to each other. So what can you write? You can write it. Am I right?
Yes, sir.
A and B are the complements, so you can write it 0.5793. Then the C is slightly different. You said exactly 6. Exactly 6, that means equal. Exactly means
Exactly 6.
exactly 6, that means equal. 0.2 to the power 6, 0.8 to the power 25 minus 6. After that is, you can write 19 directly. Not necessary to write 6 here, 25 minus 6. So it will be 0.1633. Now, per D, we have to find the mean. Mean mu is NP. What is N? 25 and P is 0.1. So it will 2. Oh, sorry, not 0.1, 0.2. 0.2, that is 5. And sigma square equal to NPQ. So 25 into 0.2 into 0.8, which is 4. Now the standard deviation is the root 4 is equal to 2. Okay.
Okay, sir.
If you understand this math, the main thing of this chapter is clear to you now. Uh, 6 is also similar. So I'm keeping this homework.
স্যার এটা তো মাত্র পড়াইলেন, এটা এসডব্লিউ করবো?
No, I have done 5
ও সরি।
and given 6 as homework. Now number 8. Read the question carefully and tell me what we have to do. Read the question. They have said a boiler have 4 relief valves. That is 4 outcomes. That is, you can try in 4 way, right? So n equal to what?
4.
N equal to 4. The probability that the opens properly is 0.99. Is opening is our target? This is P. Yes, opens properly. Open properly. So opening properly is our target. So P is 0.99. So what is Q?
0.99.
0.99 is P. What is Q? Q is 0.01. Anyway, find the probability that at least one opens properly. Find the probability that all 4 open properly. So let's go to number 8 here. N is 4 because there are 4 bulbs. The probability of their opening is 0.99, so not opening 0.01. Check on right fx as 4c x 0.99 to the power x 0.01 to the power 4 minus x. This is actually b4 0.99. Now a at least 1 is opening, so x at least 1 greater than or equal to 1. If we want to find at least 1, we have to calculate x equal to 1, 2, 3, 4. Though this valid, it's can possible because for calculating 4 probabilities doesn't matter at all. But we will use more simple. If you taking just complement 1 minus p x equal to 0. So this is 1 minus 4c0, 0.99 to the power 0. 0.01 to the power 4. After calculation, you will get 0.999 and so on, because it will continue up to 9. Then B, all 4 open, so Px equal to 4. You get 4c4, 0.99 to the power 4, 0.01 to the power 0. You will get 0.961. Do you understand?
Yes, sir.
You can see this maths are easy. Okay. Number 9. Suppose that the percentage of American drivers who are multitaskers. Multitaskers means they are doing many things at a time. Like student doing classes, they also tapping their mobiles, they are having their teas. So many words they are doing at a time. It's called a multitasking. You understand? Also, the American drivers are multitasker. Right? In the drive, they used to talk on the cell phones. They used to take the drinks, and so many things they can do. And she said that 80% are multitaskers, so 20% are not multitaskers. Here they have selected 20 drivers, and it's 20. How x is distributed? That is what is fx. They have to find the mean, variance, and standard deviation. Also, they have to find these probabilities. So let's go. This is 9. Here n is 20, as they have taken 20 drivers. Probability of multitaskers is 0.8. So probability of not multitasker is 0.2. The first question, how x is distributed? That is what is the probability mass function. Definitely they are independent. So 20cx 0.8 to the power x 0.2 to the power 20 minus x is a PMF. You have to find mean, variance, standard deviation. The mean mu is NP. So 20 into 0.8 is equal to 16. Variance NPQ 20 0.8 into 0.2 3.2. Standard deviation SD root over 3.2. You can keep here. Also, you can write a decimal point. Then there are some properties that are required. See, for first part, it was A, it was B. The first part is exactly 15. P of x equal to 15. So 20 C 15, 0.8 to the power 15, then 0.2 to the power 5. We'll get the probability. Then it said 2 probability x greater than 15. So greater than 15, since this is greater than, so you just start from p x equal to 16 up to what? Hello?
जी sir.
From 16 to
20.
20 you have to consider. Now put in fx, put x equal to 15, 16, 17, 18, 19, 20, and calculate them using the calculator. After the total simplification, you will get the result 0.6296. Finally, they've asked to find p of x less than or equal 15. Can you tell me what actually it is?
So, এটা মানে কি আমাদেরকে মানে ওই 1 থেকে 15 পর্যন্ত আমাদের কাউন্ট করতে হবে?
Why? You have the
ওকে,
15 already in your hand. Use the complement simply.
yeah.
That is, in each of the maths, you have some. You can apply some technique to make this easier, right?
1 থেকে ওই উপরের রেজাল্টটা মাইনাস করে দিলে আমার হয়ে যাচ্ছে।
Exactly. That is, in each math, there will be some hidden techniques to do this more comfortable. But
স্যার
still,
একটা
it
কোশ্চেন
will
আছে।
some. Yes.
যে মোমেন্ট জেনারেটিং ফাংশনের কি আমাদেরকে প্রুফগুলা বা থিওরেমগুলো পড়তে হবে নাকি ওই রিলেটেড ম্যাথগুলাই থাকবে?
Only the maths. No,
থিওরেম পড়া লাগবে না তাই না মোমেন্ট জেনারেটিং ফাংশনের?
no.
Okay,
Only the maths. You have to apply them.
Okay.
But before exam, you have to at least study once how we got them. Because we need to
এই
make the
মোমেন্ট
basic
জেনারেটিং
clear.
ফাংশনটা স্যার মুখস্থ রাখাটাও অনেক বিদঘুটের তো মুখস্থ রাখাটাও একটু কঠিন, মানে একটার জন্য একরকম মোমেন্ট জেনারেটিং ফাংশন।
Exactly, you are right. We did the 9, so 10 is homework. Now 11. What should we do for 11? Read the question 11 and tell me what we have to do. Look at this. They said a random variable x has a binomial distribution. Fine. They're given two quantities. One is mean, another is variance. Nothing else. And they asked to find p x equal to 4. That is, from mean and variance, we have to find the n, p, and q, and finally use them to find the p of x equal to 4. So this is 11. No, mu equal to np, and here given mu equal to what? 6. Take this as equation 1. Also we know variance equal to NPQ, and here given 3.6. Take this equation 2. Do you understand this?
Yes, sir.
Now, first we are going to find Q, because if we divide 2 by 1, here Q will remain, and 3 by 6 by 6 equal to 0.6. Since Q is 0.6, what is P?
0.4.
0.4, no problem at all. Now put the value of P at 1. If you put P 1, you will get n 0.4n. 0.4n is equal to 6. So n is 6 by 0.4. Can you calculate it? This is 15. This is what?
15.
Okay. So we got everything. Since we got everything, we can write easily we can write now fx, that is the PMF. 15 cx, p is 0.4, so 0.4 to the power x, 0.6 to the power 15 minus x. You can see now everything in our hand. Just put x equal to 4. So p of x equal to 4 is simply 15 c4, 0.4 to the power 4, 0.6 to the power 11 is the result, and after the simplification we will get 0.1267. You can see I am writing at least 4 decimal places. How decimal places? How many?
4, sir.
Okay, so you have to write at least 4 decimal places. If you write more, no problem, but don't write less. Okay.
So এগুলো কি এই যেগুলো অঙ্ক করলাম সবগুলোর ক্ষেত্রেই নাকি শুধু এই প্রবলেমের ক্ষেত্রে?
Yes. It's because 12.67, it means 0.1267. If you convert this to percentage, it will 12.67%. That is, in percentage, we are using 2 decimal places.
ওকে স্যার। মানে যখন আমরা এটাকে পার্সেন্টেজ করব তখন আমরা একটা ভালো একটা মানে বোঝার জন্য একটা ভ্যালু পাবো আর কি।
Right.
12.7%.
Exactly.
ওকে স্যার।
So, 11 is actually technical rather calculative. Then 13. 13 is slightly is crucial. It is claimed that for a particular lottery, 1 by 10 of 15 million tickets, here taken 1 by 10 of 50 million tickets, that is the technique. Actually, the probability is 1 by 10. This 50 million actually valueless. Why? We are not targeting them. We are not targeting them because from them we have already collected the probability, right? So why 50 million tickets is discussed here, mentioned here? This is simply to make you confused. Why? Why? Only for making you
confused.
Nothing else. What is the probability of winning at least one prize? At least one, so greater than equal 1. You purchase. Here n is changing. For the first part n is 10, and for the second part n is what?
15.
15. That's the fun. So let's go. But A, for A you have n equal to 10. P is 1 by 10, so 0.1. Q is 0.9. So fx is 10 cx 0.1 to the power x 0.9 to the power 10 minus x. So p of x greater than or equal to 1, we will not use it. We will write 1 minus p of what?
P of x equals 2.
So 1 minus 10 c 0, 0.1 to the power 0, 0.9 to the power 10. Out of simplification, we will get 0.6513. If you do the same, with n equal to, just the change is part B. Look at this, I am doing the same math, but here taking n equal to 15, but rest of the facts are same. P equal to 0.1, P equal to 0.9, no change at all. Here fx will be 15 cx, 0.1 to the power x, 0.9 to the power 15 minus x. Once again, the same fact, p of x greater than or equal to 1, equal to 1 minus p of x equal to 0, which is 1 minus 15c0, 0.1 to the power 0, 0.9 to the power 15. Here is changing. It is 0.7941. Okay. বুঝতে পেরেছো?
জি স্যার।
Yes, sir.
Then 17. I'll not do 17. Just get the information here for you. Your stockbroker is free to take your calls about 60% of time. That is, the probability of reaching your call is 60%. That is P is what? This is P, right? P is 0.6. So Q will be 0.4. Otherwise, he is talking to another client or out of the office. It doesn't matter. The matter is that we can reach him 60%. You call him at 5 random times, so n is 5. How many times you're calling?
5 times.
5 times, n is 5. So P is, you have P, you can write Q, calculate Q, you have n. So if easily you can write PMF, that is fx as sage as mean independence. What is the probability that he will take every one of your calls? That is, here you have to find P of x equal to 5. That is, you call 5 times and he will take everyone. So this is the first one. What is the probability that he will accept exactly 3 calls? That is the second question. X equal to what? 3. And the final question, what is the probability that he will accept at least one of your calls? That is x greater than or equal to 1. So we'll write 1 minus P of x equal to 0. You understand?
Yes, sir.
Okay. So But now 1920, what you said actually, PM MJF are always critical. Okay, define the PMF and give the values of mu, sigma square, and sigma. Find the moment generator function is given here. I am going to do B, and A will be homework. B said MT is 0.05 plus 0.75 e to the T whole to the power 12. So 19B I'm going to do. See this carefully. MT is 0.25 plus 0.75 e to the T whole to the power 12. First we'll check this is a valid moment generator function or not. M0 0.25 e to the 0 is 1, 0.75 whole to the power 12. So 1 to the power 12 equal to 1. So this is a valid moment generator function. This is what? A valid moment generating function. So we can proceed for further calculations. Now, we want to compare this with MT. We know the moment generating function for the binomial distribution is Q plus P e to the T whole to the power N. So comparing with this, we can find P is 0.75. Q is 0.25. N is what? 12, right? 1. Why? Here is 12. So,
Yes, sir.
so N is 12. Now, you have to find some things. Mu equal to NP, 12 into 75, 0.75, which is 3. Sigma square is 12 into 0.75 into 0.25, 2.25. Then standard deviation, there's no place, I am writing here, root over 2.25.
Root variance.
Right. So 1.5, that's the answer. Have a check. Then I'll go to the next math. Understand what happened there?
তো এখানটাতে আমাদের কম্পেয়ারটাই মেইন, মানে আমাদের হচ্ছে মোমেন্ট জেনারেটিং ফাংশনের সাথে স্ট্যান্ডার্ড ফর্মটাকে কম্পেয়ার মানে করে পি কিউ আর এন এর ভ্যালুটা বের করতে পারলে আমাদের প্রবলেম সলভ।
Exactly. That's the correct answer. So what you have to do actually, compare this with the your function. After comparing, you have to find the other information. So full ঝামেলা কিছু নাই এখানে. Okay, you are right. For part 1, you can see for the part 1 actually Wait, just wait. Okay, I am going to the back now. I'm going to the book now. You can see for part A, what is the basic difference between part B and A?
স্যার তেমন কিছুই না, ওখানে পাওয়ারটা স্যার দেওয়া নাই, মানে এনটা আলাদাভাবে দেওয়া নাই, এখানে এনটা দেওয়া আছে, ওখানে এন 1 হবে।
Right.
আর এখানে পয়েন্ট, এখানে হচ্ছে পয়েন্টে দেওয়া আছে, আর ওখানটাতে হচ্ছে আপনার মানে ভগ্নাংশে দেওয়া আছে, এইটাই পার্থক্য। মানে
Yeah.
1/3 বা 2/3 এভাবে দেওয়া আছে, নাথিং এলস।
Okay. So you can do this.
পার্ট এ তে স্যার কিউ হবে হচ্ছে 1/3, পি হবে 2/3, আর এন হবে 1, দ্যাটস ইট। তারপরে আমাকে ওই মিন ভেরিয়েন্স আর স্ট্যান্ডার্ড মানে ডেভিয়েশনটা বের করে নিলে হয়ে যাবে।
Right. Okay. So we can go to 20. We can go to 20 now. But in 20 there are so many functions. We can compare them with various moment generated functions. Like here, the first one is easy because they said first give the name of the distribution. That is identify which distribution this is. From which distribution you can get it. Okay. From which distribution you can get it. Oh, I think we missed one thing. We didn't write moment generated PMF here, right? We haven't write it, but we have to write it. What can we write? Fx is what? Fx is what? 12 C x 0.75 to the power x 0.25 to the power what? 12 minus x. Okay, that is the PMF. Here we say they are said we have to just name the distribution according to the moment generated function. We have to find mean and variance, and we have to calculate this, the probability. That is the extra work here. So as they say to find, nothing to do, we have to do this. So let's go. 20A empty is given as 0.3 plus 0.7 e to the t whole to the power 5. This is what? This is binomial distribution. This is what?
Binomial distribution.
Okay, this is from binomial distribution, and we get from here p is 0.7, q is 0.3, n is 5. So easily you can write here fx equal to 5 c x 0.7 to the power x 0.3 to the power 5 minus x.
5 minus x.
We can write them, and we can find mu equal to np. So 5 into 0.7, 3.5. Then sigma square npq. Wait.
3.5 into
5 into
0.3.
into 0.3, that is 1.05. Then they said to find probability 1 less than equal x less than equal to. Just p of x equal to 1 plus x equal to 2. I ask you to put the value x equal to 1 and 2 here, and then sum. You will get 0.16065, or you can write 1607. Okay. Now B. Moment generated function is given is 0.3 e to the power t, or 1 minus 0.7 e to the power t. This is exactly like p to the power t by 1 minus q to the power t. Can you remember?
So geometric distribution.
Very good. Geometric is from geometric distribution. This is from geometric distribution. So we get p equal to 0.3,
And q equals to 0.7.
0.7. So in this sense, fx is, we know, q to the power
X.
minus 1 p. And we know x equal to 0 to infinity. This is known. Now, what we discussed earlier, mu equal to 1 by p, so 1 by 0.7. Sorry, 3. So you can write 10 by 3. 10 by 3. And variance is q by p square. So 0.7 by 0.3 whole square. After the simplification, we get 70 by 99. Because 0.03, if we multiply by 10, both of the sides, you will get it. Then probability of the same manner, 1 less than equal x less than equal to, just put x equal to 1 and x equal to 2 in the given PMF, you will get 0.51. Do you understand?
Yes.
So
Yes.
you can find, if you know the formula, they are very easy, right?
Yes, sir.
It will be problematic if you forget the formula. Then C is homework. C is very similar to A, just n equal to 1. Then D. This is funny. Empty. 0.3 e to the t. Will not verify because they have said already that this is moment generated function. You can see this is not actually satisfy any distribution. So there is no corresponding distribution. Okay. So here you cannot find the mean and variance in the usual manner. I am showing the method. You can follow this. You have to find first m dot t. What is m dot t? 0.3 e to the t plus 0.8 e to the 2t plus 0.6 e to the 3t plus 0.4 e to the 4t. Then m dot 0, you will get 0.3 plus 0.8 plus 0.6 plus 0.4, so 2.1. Once again, m double prime t, 0.3 e to the t wait. Uh, 1.6 e to the 2t, 1.8 e to the 3t, 1.6 e to the 4t. If you put t equal to 0, you will get m double prime 0 is equal to 5.3. Now you know the mu equal to m dot 0 is equal to 2.1. Variance equal to m double prime 0 minus m prime 0 whole square. After simplification, you will get 0.89. Do you understand? Now, priority x, sorry, 1, 2, priority x equal to 1, but here there is a uh, facility. Here the priority is directly given. This is the priority for 1, this is the priority for what? 2, am I right?
Yes, sir.
So simply add them. 0.3, 0.4, that is 0.7. Now the last part and the last math of this chapter, E, empty, is given as x equal to 1 to 10, 0.1 e to the power tx. So you can see fx is 0.1, that is 1 by 10. This is uniform distribution. This is what? Because
Uniform distribution.
for all you will get the same probability. So this is uniform distribution. Now for uniform distribution, we know this is very easy. Mu equal to, here m is 10, m equal to 10. Why 10? 1 to 10. So how many elements there?
Sir, the loss is
10 elements. So mu equal to, we know. What do you
sir,
know?
ইউনিফর্ম মানে কি স্যার সবগুলো প্রবাবিলিটি সেম হবে?
Yes.
Okay.
So m plus 1 by 2. But one extra requirement is there. The inputs will be the natural numbers 1, 2, 3, 4, 5, so on. Okay. If the inputs say 5, 10, 20, this is not the uniform distribution. Clear?
Yes.
So m equal to 10, 10 plus 1 by 2, that is 5.5. We know sigma square is m square minus 1 by 12. So 100 minus 1 by 12, after calculation you get this. Finally, priority 1 less than equal x less than equal to. Each of them have the same priority. So 1 by 10 plus 1 by 10. Am I right? That's the end of this chapter. Please have a check if you have any problem. Then we'll start the next chapter.
স্যার মোটামুটি বুঝতে পেরেছি, প্রবলেম আপাতত নাই।
Okay. They are not a big deal if you can remember the formula. Okay. It will be problematic if you forget the formula. That will be a problem.
সো টু রিমেম্বার আমাদেরকে এগুলো প্র্যাকটিস করতে হবে।
তাহলে ভুলে যাবা, তাতে কোনো সন্দেহ নেই। Wait for a minute. I am going to the next chapter within few seconds. Today we haven't enough time, so we'll give the basic description of next chapter, not the full. When I continue with the class, then my computer is disturbs, not otherwise. It's mysterious.
স্যার এসএসডি লাগাই নিলে ভালো হয় মেবি।
already SSD ongoing.
ও মাই গড, তাহলে তো
100.
মাল্টিটাস্কিং এর জন্য মনে হয় একটা প্রবলেম করে, মানে কয়েকটা ইয়া উইন্ডোজ ওপেন থাকে তো,
Hmm.
এটা প্রবলেম করে।
Funny, once time computer was working with some 512 256 RAM MB RAM only, or 212 RAM, 512 RAM, MB RAM. But now I'm using 16.
ও মাই গড, হিউজ।
Still, it's disturbing. I don't know why. Anyway, maybe the softwares are now going heavier over the days.
জি স্যার, কিছু কিছু সফটওয়্যার আছে অনেক ভারী ভারী সফটওয়্যার, ওগুলো ইনস্টল করলে পিসি অনেক স্লো হয়ে যায়।
Hmm.
তারপর 16 GB র্যাম এসএসডি থাকলে তো স্যার মানে আসলে বাংলাদেশে যে সফটওয়্যার গুলো আছে এগুলো কোনোটা ইনস্টল করলে পিসি স্লো হওয়ার কথা না।
I'm using console, MATLAB, LaTeX,
ও
everything in the same computer.
পিসি অন করার
very,
সাথে ব্যাকগ্রাউন্ডে চলে কিনা একটু একটু চেক করবেন, টাস্ক ম্যানেজারে ব্যাকগ্রাউন্ডে যদি চলা শুরু করে তাহলে
One of my students said to reinstall the Windows, but many softwares are installed. If I do, it will be disturbing. Okay, thank you for
হাই
your suggestions.
টেম্পারেচারের জন্য এরকম হয় সামটাইমস, মানে কুলিং সিস্টেমের জন্য।
It's a good point. It's a good point. Okay, we are going to chapter 2.6, the last chapter of discrete distribution. This is the Poisson distribution. Poisson distribution is very connected to the real life. Like if your two friends are applying for a certain scholarship, what is the probability of getting this? 50%, because only two. Okay. Hello.
ইয়েস স্যার।
Say now two more people added, so now 4 people. So what is the probability now?
So 0.25.
0.25, right? Say 10 people, only 10.1.
0.1.
That is, whether the participants are increasing, that is the trials, because over the trial, after your trial by trial, the participants are added, right?
Yes.
Trial to trial, participants are added and adding over the time. That's why the trials are now not independent. The trials are not independent now, right?
Yes, sir.
And because of the trials, the number of participants are changing. That's why the probability is changing, and probability is going low and low, and once a time it stands to 0. That is, if you trial so many times, the number of participants are going to infinity. Because of that, the probability is going to 0, right? This is the main concept of Poisson distribution. That is, under a Poisson distribution, we have many chances to do, but these chances are not independent. We have many chances to do, but these chances are not independent. Okay? This is called Poisson distribution. So, the Poisson distribution will have some criteria. Here, how the Poisson is found, we found it, but I think it's unnecessary. We are not going to derive it. We'll just use it. This is the total Poisson, the PMF for the Poisson distribution. In case of Poisson distribution, the number of trials tends to infinity. That is, we have many chances to do. As the n tends to infinity, the probability of success is going to what? 0. And then we have a new quantity, lambda. Lambda is np. Lambda is what? We're taking a new variable which is called lambda. What is lambda? Lambda is called a Poisson variable. What is lambda?
Poisson variable.
Poisson variable. Though n is very large, p is very small, n tends to infinity, p tends to 0, but lambda, their product will maintain a certain number, which is lambda. So you can see fx is lambda to the power x e to the power minus lambda x factorial, x 0 to infinity. That is, you can try one time, you can one success, you can two success, three success, though the rate of success is very low. But since this is the Poisson distribution, you must show total probability is 1. Am I right?
Yes, sir.
Can you remember the Poisson series, exponential series? E to the power x. Can you remember e to the power x? 1 plus x squared by 2 factorial plus, oh, I am writing the wrong, x plus x squared by 2 factorial plus x cubed by 3 factorial. Am I right? So what will happen if I write here e to the power lambda 1 plus lambda plus lambda square by 2 factorial plus lambda cube by 3 factorial. Can I write it? Hello?
Yes, sir.
I can write it. Now, if I convert this to a series, summation series, like we can write lambda to the power x, x factorial. Can I write it? I think I can write. Okay. Now, the Poisson distribution has a form fx is e to the power minus lambda to the power x by x factorial. Now, if we take the total sum of fx, what can we find? You can see e to the power minus lambda, there is no x involved, so it will outside of sum. It is outside of sum, lambda to the power x by x factorial. But from here, we know this is what? E to the power minus lambda into e to the power lambda. So if I take the sum, e to the power minus lambda plus lambda, it will be e to the power 0. What is e to the power 0? What is e to the power 0?
1, sir.
That is, it's verified that total probability is what? 1. Okay. Total probability is
1.
1. That is what? Total probability is 1. That's the moment generated function. In the same manner, maybe today we'll not get a chance to do the maths. We'll see the basic. Moment generated function empty e to the power tx, and e to the power tx fx is lambda to the power x, e to the power minus lambda x factorial. E to the power lambda is constant, so we can write it. Here, this is the exponential form. So this is e to the power minus lambda, and this is e to the power lambda e to the power t. Very funny, right? Then if you take lambda is common, e to the power lambda will get e to the power t minus 1. Can we write it? Hello?
Yes, sir.
Yes, sir.
So this is a moment generated function. We'll check whether this is really a moment generated function or not. If we check m0 is equal to e to the lambda e to the t, that is e to the 0, 1, 1 minus 1. Once again e to the 0, which is 1. So this is valid moment generating function. Then we can take the first derivative with respect to t, second derivative with respect to t, as usual process. We get the mean is m dot 0 equal to lambda, and the variance m double dot 0 minus m dot 0 whole square after calculation once again lambda. So the Poisson distribution is a special distribution for which both the mean and variance is what? Lambda. Mean and variance is lambda. So what is standard deviation? What is standard deviation? Root lambda. Okay. বুঝতে পারছো?
Yes, sir.
Also, you can find them using the expectation, but I think not required. After so lengthy calculation, you'll get the same, so no problem at all. I'm going to show only one example now. Leave the appendix. We'll not use it. We'll do the calculator. We'll use the calculator. Let x have a Poisson distribution with mean lambda equal to 5. Use the table, just leave it. If lambda equal to 5, then the effects here on the variable lambda e to the power minus lambda 5. Then lambda to the power x, that is 5 to the power x by x factorial. X is 0 to infinity. They said x less than or equal to 6. One thing, the exponential distribution, the geometric distribution and Poisson distribution have no upper limit. So you cannot write greater than. You have to always write less than. So here x less than or equal to 5, you have to write in this way. X less than or equal to 6. You have to find p of x equal to 0 up to what? X equal to 6. Just put x equal to 0, 1, 2, 5, 6 here, you will get the desired result. Also, for greater than, you have to write 1 minus p x less than or equal to 5. So take the probabilities x equal to 0 to x equal to 5 by putting the values of x here, you will get this. Also, for x equal to 6, don't use this. For x equal to 6, you have to write e to the power minus 5 to the power 6 by 6 factorial, which is the answer. Do you understand?
Yes.
Yes.
See example 1 only. We'll start from the next chapter, example 3 next day. Example 2 is unnecessary, but one thing I want to show. Sometimes some elements, the individual element have the lifetime lambda. If we have some packages, and in each package we have t elements. So how many total lifetime for every packet? Lambda t. Say in a matchbox, a stick can have lifetime lambda, and there are t number of sticks. So they will have total lifetime lambda t. Am I right? একটা যদি 2 সেকেন্ড জ্বলে 5টায় 10 সেকেন্ড জ্বলবে না?
Yes, sir.
জি স্যার।
So ওটা গুণ হয়ে যাবে, তাই না? In this case we have to use this formula. And how can we do this? We'll show this in next class. Till then we'll stop. Now the class test will be held on 12th class. up to chapter 2.6. 12 plus, okay?
Okay, sir.
This is 10th class, so you have to wait 2 more classes. The next class we will complete this chapter. This is a small chapter actually, and we'll start chapter 3.1. Until
স্যার
then,
নেক্সট স্যাটারডে তাহলে ক্লাস টেস্ট
maybe. Please just remember 12 class. Okay. Any question?
No, sir.
তাহলে আমাদের চ্যাপ্টার 2টা থাকবে তাই না স্যার, মানে 2.1 থেকে 2.6 পর্যন্ত।
Right. 2.5 out of our syllabus. Okay. Remember it.
2.5 টা আমরা স্কিপ করব।
Right. 2.5 আমাদের নাই।
ওকে স্যার।
Okay. I'm going to take the attendance.